Hello, this is our fifth video of six installments here of 1.1 functions. This is going to cover from problem 63 to 82. 65 and 71 has to do with finding the operations that they give you. Notice there's A, C, and D though. I'm not doing them all for you. I'm doing the addition, the multiplication, and the division. And then 71, I'm just going to do the addition and the division on that one, because the division is really the tricky ones when you're finding the domain, at least, because that's the next part we have to do. Now, finding the difference quotient on 77, I picked one that's not too easy but not too hard on the difference quotient. This one is the difference quotient for a quadratic fx plus x squared minus x plus 4. And we just need to make sure it's simplified. There is another one that's probably a little bit more difficult on this one. I wanted to do one that's kind of middle of the road. And so if we get one that has a fraction on it, that's a little bit more difficult. And I'm going to leave it up to you guys to contact me if you need me to show you one of those. So anyway, so we're going to do the operations and find the domain. All right, so f plus g of x is just basically adding the two functions. And remember, you're adding the components. So it is x minus 1 plus 2x squared. And to add, there's nothing really to add here because they're all different terms. So there's no like terms here. So it's just 2x squared plus x minus 1. And that's assuming you want to put them in descending order, and that's what I did. Highest order to the lowest order. And so 2x squared plus x minus 1. Now finding the domain, and this one's pretty easy, because what is the domain of x minus 1? There's no fractions, there's no square roots on either one of these. So the domain on either one of these is all real numbers. So when you add them up, of course, it will be the same, all real numbers. So that's your domain, it's all reals. The next one is multiplication. Now, the multiplication is, here is x minus 1 times g of x, which is 2x squared. So you multiply the components, but this one's not even FOIL. This one's got a monomial 2x squared times a binomial x minus 1, and so you distribute. So this one's going to be 2x to the third minus 2x squared. So multiplying 2x squared times the individual terms over here gives you that. But again, f and g are both domains all real numbers, and there's no fractions in this one, so it's going to be all real numbers. But look at the next one. This is the quotient. The quotient is easy to find, but the domains are a little trickier. So f of x is equals to x minus 1 over g of x, which is 2x squared. So like I said, it's a little easier because there's nothing to combine. There's nothing to combine here. There's no simplification involved here. So x minus 1 over 2x squared, you just place the f of x on top, g of x on the bottom. But the domain is not all real numbers. The domain cannot include 0 because you're dividing by 0 if you do that. Even though g of x alone, the domain is all real numbers, it would include 0 here because it's not a fraction. But when you place g of x in the bottom, the quotient will not allow to have 0 in the denominator. So it's all real numbers except for the number 0, because 2 times 0 squared is still 0, and you'd have to exclude that number in the quotient. So, all right. Now 71, we're going to just do the additions first. So we have 2x plus 3 over 3x minus 2 plus 4x over 3x minus 2. The good thing about number 71 is they are making the denominators the same. And so they're both 3x minus 2. So all you do when you add two fractions that have the same denominator is add the terms in the numerator. So it's 2x plus 3 plus 4x, which is 6x plus 3. 4x plus 2x is 6x. And then 3x minus 2 is on the bottom. So if you notice, there's a 6x on the front and 3x is on the bottom. That doesn't mean you get to cancel these out. They're not factors. So 6x plus 3 over 3x minus 2 is our final answer, but the domain cannot include 2/3. It's all real numbers except for 2/3. So now on the quotient, f divided by g of x, you'll have x minus 1 on top and 2x squared on the bottom. Oops, wrong problem, sorry. Looking up there at the top. So f of x divided by g of x is this one I'm looking at. So it's x minus 1 over 2x squared divided by 4x over 3x minus 2. And I think I've looked too far ahead again. So 2x plus 3 on top, 3x minus 2 is on the bottom of that fraction. So it's just the division of those two terms, where you invert and multiply, and so you get 2x plus 3 on top and 4x on the bottom, because the 3x minus 2's are going to cancel. So what's the domain? Well, you're looking at the answer and you're saying, okay, the domain is all real numbers except for 0, because 4 times 0 is 0. But that's not the domain. The domain is all real numbers except 0, because that's what makes 4 times 0 0. But it cannot also include 2/3 either. And this is the tricky one. It can't include 2/3 because 2/3 would make the bottom on these both 0. So even though it canceled out there, you can't include 2/3 right here, so you can't include 2/3 no matter where you have it. So the domain is all real numbers except for 0 and 2/3. And then finally, on this one, 77, we have a difference quotient. So you just have to plug in x plus h into this one, and it'll give you f of x plus h like we did on a prior video. So it becomes, let's see, f of x plus h minus f of x all over h. That's the difference quotient. So I plug in x plus h into this. So it's x plus h squared minus x plus h plus 4. That is f of x plus h right there. Then I have to do the math. Minus f of x, which is x squared minus x plus 4. And this is all over h. So as you can tell, the difference quotient is kind of tricky here. So I'm plugging in, this is the whole thing right here is f of x plus h. This is f of x. This is all over h. So there's a lot of algebra involved here. So it's going to be x squared plus 2xh plus h squared when you FOIL that thing out. And then minus the x minus the h when you distribute the negative. And then plus 4. And then minus, okay, now this is going to be x squared minus x plus 4. Now, I'm going to go ahead and do the terms separately here. Let's see, x squared, take away x squared, cancels out. They're gone. So I don't have to worry about these. 2xh, this doesn't have an h, so it's just 2xh. Minus x, now here's again kind of tricky here on us, negative x minus a negative x. So that becomes a plus x. They cancel out too. And then the minus, the h squared, I don't have any h squares over here, so it's going to have an h squared. And then minus h, there's no h's over here, so it's minus h. And then plus 4 minus 4 cancels out all over h. So after all the terms that cancel on the top, this is what I have. Now as it stands, I'm done. The problem is this can be simplified. And you're like, wait a minute, you said they can't be simplified unless they're factors. That's the thing. This top can factor out an h. So if I factor out an h, 2x plus h minus 1 over h. So notice this one is now factored. H times another something else. So now they can cancel out. So then you have 2x plus h minus 1 is your final answer. So it seems like the problem is pretty tame, but there's a lot of algebra here that you can mess it up. So you got to be careful with your terms when you're doing a simplification, and that's the trick here. So, all right. So this concludes our 5th video of our 6th series. Thank you for watching.